the online lecture of Computer Integrated Manufacturing in Automobile Industry. I am Milan Trivedi, Assistant Professor at LJIET Institute of Engineering and Technology. So we are learning about a very interesting chapter, that is robot technology, and that we had covered the different laws, different generations, as well as the anatomy of the robot in the earlier class. Now let us understand in detail about the different kinds of actuator or the drives which are used in the case of robot technology, right? This is actually the basic part of the any robot, right? In the earlier class we had already discussed about the different kinds of end effectors or the particular grippers which is used to hold the workpiece, right? But in order to operate that particular end effector we need to use this kind of actuator, right? Coming to the actuator part, we are having this four basic types of actuator as far as robot is concerned. The first one is a mechanical actuator, second one is a hydraulic, third one is pneumatic, and the fourth one is the electric drives. Out of all these four, we can use any of the drive in order to operate the particular end effector and the manipulator. So let's get started with the first actuator, that is a mechanical actuator. Coming to the mechanical actuator, if we want a linear motion, right? Normally the robots will be having a two different types of motion, that is a linear as well as the rotary motion. So whenever we want the linear motion, we can use this kind of rack and pinion, right? So you can supply the power to the particular pinion so that rack will be moving linearly, right? Again we can use the recirculating ball screws even, which will reduce the friction to a greater extent, right? There will be a balls which will be circulating inside this spline portion, right? And as we rotate this, this particular shaft will be moving linearly, right? So these are the linear actuator. Second one is a rotary actuator. If you want to get the rotary motion, right, then we can use this kind of timing belt. We can use the gear mechanisms, maybe a spur gear, helical gear, any of the gear mechanisms we can use. We can have the harmonic drives where we want a higher speed reduction ratio, right? In such case we can go for this kind of harmonic drives, right? So these are the basic normal mechanical elements which is used for the power transmission either linearly or in the rotary way. The second actuator are the hydraulic type, but hydraulic and pneumatic actuator are similar in design. So we will club that particular topic. Coming to this hydraulic and pneumatic actuator also, we are having these two variants, that is linear actuator and the rotary actuator. The normally used linear actuator are the single acting cylinder and the double acting cylinder. Coming to the single acting cylinder, it is suggested as a single acting because the pressurized fluid will be supplied from only one port. From this particular flow port only we are going to supply the fluid. The another port is just to remove the vacuum, right? Here the spring will be there. So what will happen, in this inside first port, if the pressurized fluid has been supplied, as the pressure has been reduced, then due to the vacuum effect or due to the tension of the spring, the retract force will be automatically done, right? So that kind of cylinder is called as a single acting cylinder. Whereas in the double acting cylinder, from both the ports we need to supply the hydraulic oil or pneumatic air, right? So as shown in this particular figure, if in the case of pneumatic, if we are supplying air from this, forward stroke will happen, and if we are supplying air from this second port, then the retraction stroke will happen. So here from the both port we need to supply the pressurized fluid or the compressed air. So that is case of a double acting cylinder. Coming to the rotary actuator, we are having a different kinds of mechanisms in the case of rotary actuator. First one is a gear type. We are having three general types for the rotary actuator in the case of hydraulic pneumatic, that is gear, vane and the piston. The first one is a gear type. Again this is actually a external gear type in which the two gears will be in a constant mesh. So what will happen, as you supply the particular high pressurized fluid, the liquid will be trapped inside the teeth between these two gears, and that will transfer this rotary motion to these two gears, and low pressurized fluid will go out from the other end. So in between we will achieve the rotary motion, right? So this is the first case. This we are using normally where the higher torque transmission is required. The second one is a vane type. Here we are having this adjustable vanes in between. So high pressurized fluid is coming in between. It will be trapped inside this vane surface, and it will try to just transmit the motion to the this central uh, particular vein, right? So in between you will achieve the rotary motion, and the high pressurized fluid will lose its pressure and will be just delivered as a low pressurized fluid from the outlet end. But in between we will have this rotary motion. The third one is a piston type. In the case of piston type, this is a cross sectional view. So what will happen is, we will having this particular ring which is mounted on a shaft, right? In between that ring we are having the number of different piston cylinder assembly attached. So all the pistons are of similar size, but as this is at some inclination, what will happen is, as shown in this side view, in half of the stroke suction will happen because the piston is taking backward, right? And in another half delivery will may happen. So at the other end, the pressurized, less pressurized fluid will be delivered. So in between that, what will happen, that will transmit the rotary motion to this particular ring. So this is how the particular rotary piston type of actuator works. Coming to the electrical actuators, normally we are having this four different types of electrical actuators. That is DC motor, which is operated with the help of direct current, AC motor, servo motor, and the stepper motor. Right? Stepper motor is normally used where we require higher accuracy and precision, because that is working in the incremental step. In the case of DC motor, we can have a closed loop system, means amount of RPM you can measure easily by attaching the different sensors. You can even control that very precisely, right? But in the case of AC motor, you can't do that thing. So that's all about the different kinds of actuator. Coming to the sensors, we are having these two broad categories of the sensors. The first one is our tactile or contact type sensors, and another one is a non-contact type sensors. Contact type sensors are again being subclassified as touch sensors, force sensors, piston and displacement sensor. Touch sensors is normally a limit switch or micro switch. Force sensor, just to check how much force is being given to the actuator. Uh, for that we can use piezoelectric or force sensing resistor or strain gauges. In order to check the position and the displacement, we can use potentiometer, encoders, this linear variable differential transducers or resolvers. In the case of non-contact type sensors, we can use proximity sensors, right? We can use robot vision system and even the voice synthesizers, in which there is no contact but still we will receive the data. So this all sensors can be work as the internal sensors or the external sensor. So we are having this variety of different sensors, but these sensors, if we are using, then obviously if we summarize our earlier topic, then we are actually developing a second generation robot, right? This kind of robot are called as a clever robot. If we are not using any of this kind of sensor, then it is called as a first generation robot, that is a dumb robot, right? Now based on the requirement or based on the application, we need to identify the sensor which we are going to use, right? Say for example, up to what extent the arm is required to be displaced, that we need to find, then we can use this kind of potentiometers or maybe a LVDTs. If we need to check the rotary motion, then we can go for the encoders, right? And if sometimes we need to push this any of the object, right, then we need to use the force sensors. For that we are having this different choices with us, that is either to use piezoelectric or the force sensing sensors or the strain gauges. About this we are already learned in the case of particular mechanical measurements. In that subject we have already learned about this different types of sensors or the particular apparatus which is measuring the data, right? The common difference between this contact and non-contact sensors would be that suppose there is touch of the particular object with the end effector, then only it will record data, then it is called as a contact type sensors. But from the distance itself, if it is measuring the data, then it is called as a non-contact type of sensor, right? Normally the proximity sensors, the robot vision system which is fitted with the cameras, right, and that is identified as a non-contact type of sensors. right? Even the voice synthesizers, that is actually we are using in the case of Google search also, right? Just we start the voice search, and as per your this voice command that will search the data. That is actually the function of the voice synthesizers, right? So we are having this different choices of sensors with us. Based on the application we need to choose a specific sensor, right? Based on the application we need to choose a specific drive even, right? So summarizing that, we need to be very specific as far as this end effector, the drives and the sensors selection is concerned, right? That's all for the today's lecture. Finally, thanks for watching.